Securing remote access. All right. So until now, we've talked about getting things connected. We've talked about the need for security, and we've shown you a few different tricks for different types of security, like port security and securing our routers and things like that. But we want to make sure you're aware that as we start configuring network devices and as you grow your network career, you think of things from a security perspective, especially as you're doing configurations on network devices. So let's start off and kind of review a little bit Telnet versus SSH. Okay, the reason Telnet gets such a bad rap, and you'll see blog posts that are like, never use Telnet, right? I know because I wrote one about that. And in it, we just kind of showcase why, because a lot of times we try to explain, hey, whenever you're managing devices on your network, you may be thinking, well, it's my network, I'm on the inside, and I'm just managing a device in my network, okay? So what difference does it make if I use Telnet? Well, let's take a look. So let's say I've got a pretty simple network topology and I just have a couple switches here. Maybe that's my distribution switch, and then it's connected to this switch, and then I'm connected over here. Okay, so this is me and I am host A, and I want to communicate with this router here. He is .1 on the network, and let's just say that I'm .5. Okay, it doesn't matter the rest of the subnet, that's just what it is. So I want to communicate with this guy on .1. Well, if there's anybody in my traffic path whatsoever between my client and the router, or the switch that I'm managing, or any of these devices that I'm managing, whenever I start managing a device via Telnet, that session going through here is sent in clear text. Okay, and whenever I say clear text, I mean clear text. Like, you will see me typing the username, and you'll see the password, and yeah, there's not anything I can do to stop it. It doesn't even take like hacker tools or compromising anything or anything like that. It's just clear text traffic. It's just like if we were to start a capture right now and capture going to some web page that uses HTTP, for example. Those weren't designed with security in mind, okay? And the worst thing is let's say I get used to just kind of quick and dirty Telnet configurations on my LAN. Well, what if I have to remote in one day, right? And this is coming from the outside world, okay? So somebody says, hey, I need you to, something's wrong with the router, Chris, I need you to manage that. Well, the next thing you know, I'm not even thinking about it because I'm worried about this network outage, and I connect to this router to manage it remotely, and because I'm not used to doing secure shell, I just open up a Telnet session, right? And the next thing you know, anybody out here on the public internet can now learn my username and password. And like we said, if we compromise any lower layer of the OSI model, you get access to all the layers above. That's the way you got to think about security. Okay, so let me say that again. If I compromise any lower layer in the OSI model, I get access to all the layers above. That's the way you have to think about network security. So with that said, it's not even that difficult to set up secure connections. You just have to understand what's secure versus what's not secure. So the first security protocol for network management we want to look at is SSH. It's been around for a long time, and the thing that a lot of people don't realize about SSH is it is a two-way trust. Whenever I connect to a network device, I see a fingerprint for that device, and it says, hey, is this the device you want to connect to? Are you sure this is the device you trust? I could optionally also use certificates for it too. That's a little bit more complicated setup, but at a minimum, I set up the device, I trust the ID of it. It's a two-way trust. He trusts me because I put in the correct username and password. Then the session's established, and that entire session is encrypted. So if anybody is able to capture those packets, they're not going to be able to see my username and password. And SSH requires a username and password in order to do SSH. It also requires the device have a host name and a domain name, okay? And you'll see that in a minute. And you can use certificates with SSH and make it even more secure. Further than that, later on, whenever you want to do other things using the SSH protocol, instead of using FTP, you can use SCP. And we can kind of borrow the same security mechanisms we use and keep all of our communication to the device pretty much encrypted. And that way we don't have to worry about people compromising our network at the lowest layers, because if I compromise a network device, guys, it's game over. Okay? All right. So how do we configure these two protocols? And I do want you to know how to do both of these, but I also want to impress upon you the need, and I hope I have already, to make sure you focus on learning SSH You might need to know Telnet, configuring Telnet, simple Telnet stuff for one of the exams out there like a CCNA or a Net Plus, but I want to make sure that that you understand SSH is definitely the way to go. It's where you want to be. So Telnet is very simple. You could just do an enable secret password. You really you will need a username and password for Telnet to work. Okay, so enable secret. You got username, password, Cisco, and the reason you got the enable secret there is because we haven't set up AAA. We'll talk about that in just a second. So you need an enable secret password at a minimum. You need a username, Chris in my example, and then password Cisco. And the other thing you want to get out of the habit of too is by not putting in the secret command whenever you do this. So if I use password, that means this will be stored in clear text as my username and password. So if I do a show run and somebody happens to be walking behind me, they would see my password over here. So that's not a good idea either. Get in the habit, guys, of doing username, mostly get in the habit of doing a privilege level and then secret for the password. And so you can just change password to secret and then put in Cisco, and that will go ahead and hash that password for you. So if anybody's walking by and they're looking at the code, they would see username Chris, but they wouldn't see any passwords. Okay. Then we go under our V2Y lines, which are our virtual terminal lines to manage the device. Login local. That means log in using the local username and password database. Now that we've covered that, we've covered our grounds, let's focus on SSH access. So SSH requires a little bit more because we are setting up that trust. So one of the things is we've got to have a host name on the device, and of course you set that up right whenever you set up a new device. You also want to configure the domain name. Now, once you set up your SSH keys, especially if you start using certificates, you're not going to change the host or domain on that device anymore. So if you're just messing around and you haven't really put together a document saying this device is going to have this host name and this domain name, don't worry about doing something advanced like certificates because you're going to break SSH if you change the host name or the domain name. Okay? Or you'll break the keys that were generated with that host name and domain name. All right, so aside from that, let's just focus on this for now. We go into global configuration mode. We already have a host name of R1. We're given a domain name, Cisco, for example. Then we're going to use the command crypto key generate RSA keys, and 1024 is the modulus size. We want 1024 minimum. It's going to say is 512 okay? Well, no, it's not. We want 1024 minimum because we want to use SSH v2. Okay, that's the standard now. Then we put in username and password, but again, we would put in username Chris and then secret and the secret password. Okay. I just put this in here so it's easy to understand what's going on instead of some hashed value, right? Then under line V2Y for 0 to 4, and some devices nowadays they go all the way up to 15. So you might do line V2Y 015. That way you can cover kind of all 15 sessions. And then we can use the login local command. Now under login local command, if that's all I did and I did nothing else, then Telnet would still be allowed to this device. Okay, all transport is allowed to this device unless we lock it down. So the way we lock down and say we're only going to allow SSH to this device is to use the transport input command and then specify SSH is what's permitted. Then Telnet is no longer permitted to manage that device. And again, this is good for routers and switches, any iOS capable device, autonomous APs, any of that, same stuff. Another thing we want to do to secure remote access to our devices is make sure not just anybody can access the management interface on our device. Okay? So a lot of people think, well, I'll just add an ACL to one of my, gigabit Ethernet interfaces, right? Well, if you think about that, let's say I've got a gig 0 interface there, and I've got a gig 1 0 interface here. There's a difference, guys, between traffic that's going through the router and traffic that is destined for the router. No matter what ACLs I applied on these interfaces, okay, if the request is to the router, then it's not going to block any of that. You would still be able to see the router even if I put a deny any on that interface. because I'm not trying to route through the interface. I'm trying to reach the router, which would have an IP address that I could reach. And in that case, I'm accessing its VTY lines. Okay? So how you would keep somebody from particular networks from accessing, let's say we've got one management network at the company, and it is this 192.168.10 network. That's the only network that should be managing this device. Well, then we create an access list. We use the access list to classify the traffic, and it could have multiple statements. If we have two management networks, it could be 192.168.10.0, 192.168.20.0, whatever. That's fine. We've got a permit statement at the end of every ACL, so an implicit deny. So then we go under our line VTY, IP access class, in this case, 10, and it's inbound. Okay, so IP access class 10 and inbound. And then if you try to access this device from any other LAN segment, it would not be allowed. So that's a good way to do that. So using SSH and a combination of ACLs will help you secure the management plane of your devices, right? All right, so some other protocols to consider, guys. SSH is one thing. Some devices allow HTTPS for management and or to be managed by NMSs of various types. So if you're going to use HTTP, you don't use HTTP. You want to use HTTPS for that. Okay, so that's a whole other setup to do HTTPS if you're going to allow that, or if you're going to allow somebody to get on that device and use the little web monitoring thing that some devices have with Cisco. Also, file transfer. Don't use FTP. FTP, all the data and all the commands and the username and password is sent in clear text. Okay. Use SCP for copying files to and from your devices. Okay, so SCP is a good way to go if you need to copy configuration files or if you need to copy iOS upgrades to your devices. Use Secure Copy. There's a cool app for Windows called WinSCP. It's free. Get used to using that, guys. Okay. Also, for the management, day-to-day management, polling, and all that kind of stuff for the health of your device, for the telemetry protocols, SNMP is not secure. Okay. And there is default communities typically in a lot of network devices out there, which is a kind of a security hole. You really want to configure SNMPv3. You're going to need a username, password to set up the device. Okay, we no longer use community names with v3. It's just username, password. v1 and v2 use community names, but there was no encryption, no authentication, just a community name. So if I was able to access the management network, I could quickly figure out what all the SNMP devices were using and potentially compromise those devices. We don't want that. So we want authentication and encryption, and then that NMS can manage our network device. Okay. Finally, as a best practice, if you have any sizable organization, get used to using AAA on the device for granular role-based access control. Using AAA on a network device, this is why we have those privilege levels. Okay. So I can have a person actually access the privileged exec commands and maybe run show commands to see how interfaces are doing, to make sure they're up and to make sure they're transmitting traffic. But I can make it so they couldn't, so they couldn't change an IP address or they couldn't change anything. So in other words, I can give them granular access that I need them to have to do their job, but maybe they're not in a role. Maybe they're a junior network technician. They're not in a role to do any change on the device, but I do want them to be able to troubleshoot. I don't want them to be out there with their hands tied behind their back. Okay, and you can set this up locally. If you only have a few devices in a branch office, you can set this up locally on those devices to give people the access they need to have without allowing them to make mistakes that could cause outages. But if you're in a big environment, use a centralized AAA server. It'll make things easier. You'll have single sign-on for all your device administration. And if you use a Cisco Secure ACS server or a Cisco Identity Services Engine or Aruba ClearPass or something like that, enterprise AAA server, then you're going to have advanced security options for managing all your devices. Okay, TACACS is the way to go. Radius is definitely good to use. Okay, And whenever we talk about this, guys, we're talking about the protocol that's used between the device you're going to manage and this AAA server. Okay, and this is for device administration. So I got a AAA server. This is the device I'm logging into. Well, it could use Radius right here, or it could use TACACS. But this is only for network device administration. Okay, TACACS would be better because it is a tunneled session. It's more secure, and you can get very granular control over who can do what on that device. So instead of trying to create a policy on each device, you can create the policy centrally and enforce them enterprise-wide kind of thing, right? So in the lab, though, we're going to focus on making sure we understand how to secure remote access to our devices, setting up SSH, and making sure we don't use Telnet or any type of clear text passwords in our configuration. So that's what we're going to do now, and I will see you in there.